Hi everyone, this section is going to be giving a little bit of background information for the rest of the presentation. Here I will be talking about three of the major fires that took place during the end of 2019 through 2020. Because of COVID-19, these fires have not seen very much publicity, which means that they could happen again. To start off, we have the Amazon fires. The Amazon plays a huge role in the inner workings of the ecological world. It covers 8 million kilometers and holds the largest amount of biodiversity. It balances both the global biodiversity as well as the global carbon budget. The Amazon plays one of the key roles in the global water cycle system and helps to stabilize global climate and rainfall. Since the 1970s, 17% of the Amazon forest has burned due to wildfires. In July of this year, the number of wildfires increased 28%. If these fires are not stopped, the Amazon will be turned into one of the world's largest carbon faucets, releasing more carbon into the atmosphere than it has ever absorbed. Gradually, this Amazon will turn into a savanna. The burning of this many fuels leads to poor air quality, which then leads to health problems. Not only does the burning of the forest cause health problems, it's causing an extinction to certain species as well. The fragmentation of tropical rainforests cause spillover, leading to diseases such as COVID-19 by increasing the potential point of contact between humans and wildlife. The Amazon could become a future hotspot for emerging diseases, some of which are way worse than COVID-19. Australia had the worst fire season on record this year, consisting of 15,000 fires across all of Australia, 28 million acres burned, which is an area larger than Denmark. These fires also produced black carbon, which is harmful to human health and climate change. These plumes of black carbon traveled more than 7,000 miles from the fires. In the path of these fires were 3 billion native animals. This caused a significant threat to the extinction of the population of koalas. At a minimum, 5,000 koalas were estimated to have died because of these fires. Animals were not the only ones dying either. As of January 31st, there were still 50 fires burning in Australia. At this point, 33 people were killed, including 4 firefighters. 27 million acres were burned. As of September 14, 2020, 24 more people were killed, and 2,000 homes were reported to have been destroyed. The fires we have heard about the most were in California, and they are still burning. In 2020 alone, California saw 9,177 wildfires that burned over 4,194,148 acres, destroyed 10,488 structures, and killed 31 people. The intensity of these fires were increased due to human-induced climate change, a very, very dry January and February, a mass die-off of trees, and poor forest management. Most of these fires were due to thunderstorms followed by winds that spread the fire, and a heat wave which did not help to stop them. In California, wildfires have been aggressively suppressed in the recent years, which caused a buildup of fuels. The buildup of fuels increased the risk of large uncontrollable fires. The increase in the population and development also contributed to the increase in flammable tinder. Climate change contributes to the ongoing drought and high temperature, which are higher than they would have been without human-induced climate change. California did also have a suspected case of arson. Ivan Geronimo Gomez was charged with arson relating to the Dolan fire. And there was also a gender reveal party, which started a major fire in California. California usually has a seasonal risk, which peaks around July or November, and does not end until late November.
Hi everyone! In this section, I'll be talking about some statistics and causes of human-caused wildfires. According to the National Interagency Fire Center, humans cause an average of 60,467 fires a year. And according to the Insurance Information Institute, humans cause 90% of all fires in the United States, 67% of which are started in southern and eastern areas. It follows that Alaska reported the fewest human-caused fires. Also, fires seem to be increasing yearly. From January 1st to November 6, 2020, there were 48,858 wildfires compared with 45,255 wildfires in the same period in 2019. In addition, 6 of the top 20 largest California wildfires occurred in 2020, according to CAL FIRE's list. Climate change seems to increase the frequency and severity of wildfires. These fires are also far-reaching on lands. Since 2000, about 6.9 million acres burned yearly on average. In the USA's average population density, this would cover more than 8 billion people's land. In addition, about 8.6 million acres were burned in the 2020 period, compared with 4.6 million acres in 2019. For geography, nearly 36% of all acres burned by human-caused fires are in the southern area, and 4.5 million U.S. homes were identified at high or extreme risk of wildfires, with more than 2 million in California alone. These can also cause huge costs. For the last 10 years, the average federal firefighting cost for the Forest Service was around $1.5 billion. From approximately 150,000 wildfire situation reports from 1999 to 2014, researchers found that about one-third of all firefighting costs go to fighting human-caused wildfires and half go to protecting houses. A major source of human-caused wildfires is the WUI, or a wildland-urban interface, where houses and residential communities mix with undeveloped wildland vegetation. Even though this only makes up 10% of U.S. land area, almost one-third of wildfires start there. Additionally, 97% of all fires in the UWI are caused by humans. Most fires in this area are less than 4 square kilometers in area, but these fires are responsible for threatening 92% of homes and also came within 1 kilometer of 59 million homes over a study period of 24 years. An additional million homes come within the boundaries of wildfires. The combination of more homes built, warmer conditions due to climate change, and more fuel loads due to more fire suppression is therefore leaving exurban areas much more prone to wildfires. What causes these numerous fires? There are many human-based causes, which can be accidental, intentional, or from an act of negligence. Campfires can be left unattended. People use campfires for cooking, warming, or bonfires, but accidents or mistakes can cause these to spread. In 2013, a hunter's illegal campfire in Yosemite spread and burned more than 66,000 acres. The burning of debris. Fire can spread from any fire originally ignited to clear land or burn rubbish, garbage, crop stubble, or meadows. A property owner's burning debris pile ignited a wildfire in the Sierra foothills in California. Although it took place under allowed conditions, drier conditions let it spread. Negligently discarded cigarettes. Lighting tobacco and smoking without properly discarding cigarettes can cause a lot of damage. According to the National Fire Protection Association, cigarette-caused fires result in more than 1,000 deaths, 3,000 injuries, and $400 million in property damage yearly. In 2001, for example, a motorist driving on Interstate 8 in San Diego County flicked a cigarette butt onto the center median and sparked a fire that burned more than 10,000 acres and destroyed 16 homes. Intentional acts of arson. This is illegal or unauthorized burning that causes intentional damage. 180 people are facing legal action for fire-related offenses since late last year in Australia, 24 of which have been charged for allegedly setting some intentionally. Sparks can be thrown from equipment and railroads. Smokestacks or brake shoe failure along with uncleared vegetation near tracks can start fires. The 416 fire in Colorado burned 55,000 acres and was caused by embers emitted from a coal-powered train locomotive. Power lines can cause wildfires. Once damaged by something like weather, wires can contact trees or other combustible material, resulting in sparks, smoke, and fires. The Camp Fire, California's most destructive and deadly wildfire to date, was ignited by a faulty electric transmission line and destroyed 19,000 buildings and killed 88 people. Fire play. Matches, fireworks, lighters, or other forms of entertainment can cause fires when not used properly. A fire sparked by a pyrotechnic device at a gender reveal party this year burned more than 10,000 acres in California. Naturally caused wildfires only make up 10% of all wildfires. Causes for these are most frequently lightning. There are also volcanic, meteor, and coal seam fires. But in general, humans cause the majority of the devastating effects that come with wildfires. They have doubled the length
Hello. Today I will be discussing climate science in relation to wildfires. Carbon dioxide and greenhouse gas emissions are a major effect of wildfires. As you can see on the left-hand side, there is a climate feedback loop in relation to the wildfires. So the rising temperatures cause drier conditions and longer fire seasons. And then there are larger burned areas as a result from the dried out and dead vegetation, and these can easily be sparked with fire. Emissions from fires increase as they burn over expanded areas and cause more frequency and longer fire seasons. More carbon in the atmosphere accelerates the warming and leads to temperature rise, which starts the cycle back over again. Wildfires release large amounts of carbon dioxide, black carbon, brown carbon, and ozone precursors into the atmosphere. These emissions affect radiation, clouds, and climate on regional and global scales. They released an estimated of 9.5 million tons of greenhouse gases into the atmosphere just from combustion. Combustion is the only part of the story because dead trees also release carbon dioxide as they decay. Carbon dioxide emissions from decay are generally 3 times greater than emissions from combustions because large quantities of wood and other plant material remained unburned after a forest fire. To put these emissions from combustion and decay into perspective, they are equivalent to adding an estimated of 7.7 million more cars onto California's highways for 1 year. As you can see on the left-hand side, the rising temperatures and atmospheric carbon dioxide concentrations. Each year, you can see that these are both increasing rapidly. And on the right-hand side, you can see that the emissions are also increasing rapidly, and this shows California, Oregon, and Washington's emissions. This buildup of greenhouse gases in the atmosphere is warming the planet rapidly. 2019 was the second warmest. The past decade was the warmest on record. Emissions contribute to the global temperature rise, which accelerates the climate feedback loop. While emissions from fires contribute to the warming, burning fossil fuels is the leading source of emissions. Climate change is a main contributor to the wildfires. On the left-hand side, you can see that the average annual temperatures are increasing, and this shows California, Oregon, and Washington. Rising temperatures are causing a warmer and drier climate, which means there is no moisture in the soil. Because of climate change and the temperatures are continuing to rise each year. The vegetation is more flammable because of this, which causes brush fires and more. The intensity of fires are also increasing. As climate change progresses, the area burned is expected to double for each degree of warming. These are satellite images of a California wildfire. As you can see, the wildfires are growing in intensity as they can now be seen from space. For each degree of warming, the area expected to be burned is supposed to double. More than 4 million acres of California was burned this past year in 2020. There are more than 8,200 fires in California this year. On the left-hand side, there is the active fire, and then on the right-hand side, you can see the healthy vegetation. Debris flow is another effect of these wildfires. It is a fast-moving landslide, and In the picture, you can see the after effects of debris flow. Studies have shown that there is a correlation between the frequency of debris flow in areas that were recently burned. It is very dangerous in taking, and when there is heavy rainfall, the land that is damaged is more likely to have these debris flows. The air quality has suffered because of these wildfires. As you can see this is a picture of the air quality in California during the wildfire season. You can see that it's hazardous and very unhealthy. Dangerous organic chemicals and nitrous oxides are being emitted by these wildfires that form ozone and organic particulate matter, and this furthers the climate change that's happening. This just keeps the feedback loop going, and more wildfires will occur.
And so wildfires also cause human displacement, loss of personal items, and it takes a toll on mental health. Exhaustion, stress, depression, and health impacts are all secondary results of uncontrollable wildfires that spread across the world.
Okay, hi everyone, it's Ella, and I'm going to be discussing wildfire prevention policies. First, I'm going to discuss forest management techniques that include mitigation policies, then forest management that uses adaptation policies, and then international environmental and climate laws and policies relating to preventing fires. I would first like to reiterate a main premise that has been touched on, being that climate change does and will continue to have a significant influence on wildfire intensity and management. This first graph shows the overall effects of climate change on wildfires and how it has basically doubled the acreage burned. And the second graph shows the cycle of how climate change fuels wildfires. Temperatures are rising, snow will melt sooner, so forests become drier for longer periods of time, and fires get worse, more drastic, larger, and much harder to control. While there are few climate-related federal and national policies in place, there are many state and regional initiatives that have been widely successful. And for the first time in history, climate science and policy are beginning to unite, which is really exciting. First, I'm going to discuss adaptive forest management. Climate adaptation is quite literally adapting to the climate change that's already in the pipeline, is already going to happen. Adapting to a life in a changing climate involves adjusting to actual or expected future climate. Some issues we need to adapt to in forest fire management involve drought, disease, and insects, particularly bark beetle infestations that are increasing with drought. The United States Forest Service National Cohesive Wildland Fire Management Strategy is a national collaborative to use the best climate science available to work towards their goals of building resilient landscapes, fire-adapted communities, safe and effective wildfire response. And the focus on resilient landscapes is particularly important for the U.S. Forest Service. The John D. Dingell Jr. Conservation, Management, and Recreation Act it consists of over 100 bills for national conservation presented by the Senate and signed into law by President Donald Trump. And some premises of the act include coordinating federal, state, tribal, and local assets, recovering hazardous fuels, treating Department of the Interior and U.S. Forest Service and Department of Agriculture regulated lands for invasive species, water quality, flooding, erosion, and forest restoration. This act also includes Executive Order 13855, promoting active management to reduce wildfire risk. So now I'm going to discuss mitigation techniques in forest management. Climate mitigation is reducing emissions of and stabilizing levels of heat trapping greenhouse gases in the atmosphere, basically meaning reducing anthropogenic drivers of climate change before they're already in action. Forests are really interesting because they're natural carbon sinks, meaning they can store carbon and actually sequester carbon out of the atmosphere. So their management is really important in mitigating climate change. A main premise of mitigational forest management is just improved management techniques through the use of thinning forests and prescribed burns. Flagstaff, Arizona has issued bonds to thin their forests, and productive burning has been very successful in Yosemite. Using prescribed burns, which remove dead, flammable vegetation that can allow future fires to get out of control, has been really successful for Yosemite in improving the resilience of giant sequoias and other trees and protecting their stores of carbon. The Yurok tribe has the Cultural Fire Management Council with the Nature Conservancy and U.S. Department of Agriculture, and they have been implementing prescribed burns for a long time. And that image on the right is a member of the Yurok tribe doing a prescribed burn. The Community Wildfire Prevention and Mitigation Report is a California report attempting to analyze risk of fires and adapt to future fires. So it explains that more than 25 million acres of California wilderness are classified under very high or extreme fire threat. And it includes Executive Order N0519. This order identifies 35 priority fuel reduction projects to protect over 200 communities in California. The projects include removing dead trees and vegetation, creating fuel breaks, and ingress and egress corridors. Some other mitigation techniques include international carbon emission reductions treaties. So let's talk about some of those international forest fire management strategies. Some international treaties include the Kyoto Protocol and the Paris Accord, which we've all learned about this semester. While these are not specifically aimed at protecting or mitigating forest fires, efforts to reduce greenhouse gas emissions and concentrations are somewhat intended to preserve natural ecosystems. In Australia, we have all heard about the Black Summer of 2019 and 2020. More than 18 million hectares burned and more than 1 billion animals were affected in the bushfire. However, Aboriginal peoples in Australia have been managing fire for over 60,000 years in cool conditions, often after recent rainfall, to create slow-moving, low-severity fires. So they're still using prescribed burns that they have been using for many, many years. And they're also using collaborative management, which is very interesting and unique. In Brazil, they're expecting quite a bit of effects of climate change to affect the Amazonian forests. By 2100, precipitation will be reduced by 20% and temperature increase will be anywhere from 2 degrees to 8 degrees Celsius in the Amazon rainforest. I've listed the 3 levels of government that mitigate forest management in Brazil. And some of their strategies include satellite monitoring for fire detection, which has been really successful and interesting. If you look in the satellite image in the bottom right corner, you can see actually the smoke from the Amazon fires in that image. So technology is really advancing and helping us address these problems. They're also investing in planning, training, and funding to prepare for fires before they happen, and supporting small-scale farm communities, including indigenous lands, to use farming practices that are more controlled in preventing forest fires. A couple limitations of their mitigation is that the budget is prioritized for firefighting instead of training and prevention methods. Additionally, PREVFOGO, the National System for Forest Fire Prevention and Control, only legally protects about 1.42% of the Amazon, and the rest is controlled by municipal and state levels. So in some ways, they do have their hands tied in that part. I'd like to end this presentation with a hopeful quote from the Bush Heritage website. Right-way fires encourage regrowth and regeneration. Although it is overwhelming to see all of these disastrous fires across the western United States and other parts of the world, I think it's important to remember that this is a monumental time in history where science and policy are coming together to address these issues. And I do believe we're on the cusp of an environmental movement to battle climate change. So I wanted to end the presentation with some really adorable pictures of some native wildlife from the Amazonian rainforest and Australia, to remember that there is a right way to do this, and we can fix this, and we are getting onto the right track. So thank you guys so much for your time, and I hope you learned something from this presentation.